welcome to 4.1 and 4.2 all together.
You're so embarrassing. I don't know what happens with you. Whatever.
We have two learning objectives, and you're going to see why we squashed them together here. The first is to identify questions suggested by patterns in data, and the second one is to estimate probabilities using simulation.
All right, let's do it.
Yeah. So just some, essential knowledge because we like it. Patterns in data do not necessarily mean that variation is random. What?
Yeah, I was like, break that down for me. So, like, if I see something happen a couple times, that doesn't mean that, I can believe that. So if I flip a coin 3 times and get heads 3 in a row, doesn't mean the coin's broke, right?
Right.
Okay.
Absolutely. Random chance process generates results that are determined by chance.
So, like, if I do something, anything can happen.
Oh, yeah, that makes sense.
Yeah, like you're getting the Mr. Bobby-ized version.
An outcome is the result of a trial of random processes.
So whatever happens, that's the outcome.
An event is a collection of outcomes.
So, like, a bunch of things that happen if I do something over and over again. Go on.
It's an event? Oh, okay.
Yeah.
A simulation is a way to model random events, such as simulated outcomes closely match real-world outcomes.
Like, sometimes I really can't do things, so like we use computers to fake it and approximate it.
Yeah. The relative frequency. Wow, we haven't seen that word in a while.
Yeah. Like,
the relative frequency of an outcome or event is simulated or empirical data can be used to estimate the probability of that outcome.
So, like, I do something and I track it and use that to estimate how likely it is to happen.
Oh, yeah, that makes sense.
Yeah.
The law of large numbers states that simulated empirical probabilities tend to get closer to the true probability as the number of trials increases.
And so if I'm going to Mr. Bobby-ize that one, I got to do something over and over a bunch of times to see what's really going on.
Okay, so Mr. Bobby has just taught you the whole lesson. We're done. Let's be done.
All right, we got some really cool examples, and I want to talk about some of this because we're going to, and I live near Hot Springs, and y'all live in Hot Springs, so you know what's in Hot Springs. There's lots of stuff about dice and cards and stuff going on at Oaklawn. So it's kind of important that you understand that Oaklawn's gonna make their money. You might win a certain event, but over the thousands and thousands of times the games are played and thousands of people that go to Oaklawn,
that house is winning.
They're gonna win, and you're gonna lose if you go there a lot. Now, if you go there once and win, God bless you. You're lucky.
And then walk away.
Walk away, because if you keep playing, you're going to end up giving that money back. So that's kind of what's going on here a little bit. We're looking at rolling 2 6-sided number cubes because we can't call them dice in school. Oh, I just did. I'm sorry. Anyway, if we look at these are all the possible ways that 2 dice can land. We can get a 1 and a 1, a 2 and a 3, and a 6 and a 4, and they're all listed here. How many possible ways can it happen?
Right.
Okay.
And so this is what it would be like if we added them together, right? So it's just showing you like the sum of those two. But yes, so there are 36 possible ways the individual number cubes can land, right? And
yes.
If you do that once, roll them, that's called, and look at what you got, that's called an outcome.
Mm-hmm.
If you play a bunch of times, all those are called the event.
And
simple.
So why are the 7s and the 10s highlighted here? Isn't that the ones that you win on or certain games and stuff? Like, they'll say, oh, if you roll a 7 or a 10, you win. Everything else, you lose.
Right.
And boy, it looks like there's a lot of places that you'd lose.
Right. Not a lot of winners here.
Okay.
Not a lot of it. Did you play dice growing up?
No, I would never do anything.
I mean, did you play number cubes growing up?
No, I would never roll. I would never play games. I was going to read my math book and that's what I did with growing up, read math books.
He's lying to you. Okay, let's say that I think I'm like the baller of all ballers. And I tell you, you know what? I'm a pretty good free throw shooter. Like, and
Come on, hit it. Hit
I,
it.
well, I was trying, but there's too much space between you and I.
Yeah, it's probably 30 miles or so, 30,
Yeah.
40 miles.
And so let's say I tell you that I actually make it 80% of the time. Do you believe me?
I don't believe anything you say.
No?
No,
Nothing I say.
you're a big fat liar. I don't believe
All the time.
you lie like a rug.
Okay, so what I could do then is we could run a simulation. Da-da.
Because we're not going to go out. It's 6:45. It's dark out. We're not going to go outside and play basketball right now.
So let's say I shoot the ball and I made it. And I shoot it again and I made it again. Looks like I am at 100% of the time I hit it right.
Oh, you only threw 2. That's not that big a deal. Anybody, I can make 2 free throws on a good day, and I'm terrible.
Oh, that's 3 in a row. I'm done.
No,
I
that's
always get it.
No. Remember what I said about that? We got to do it a bunch of times to see what's going on.
Okay, so how many times do you want to do it? 3 wasn't enough.
No, I want at least like 10 or 12.
Okay, so how about I do 10 more? That'll be 13. Oh no. Oh good.
Oh, you stink.
Oh dear. Well, I mean, it's not that bad. I've hit it 77% of the time. I think it's 80% is good.
That ain't 80. 77 ain't 80.
So do you feel like 13 shots was enough to say I'm at 80%?
When it's going my favor, I do. See, that's what a lot of people would say. They would play the game until the odds are in their favor. But if we were going to do this, like a true basketball player doesn't actually just ever shoot 13. I mean, they probably shoot 100 practice shots in practice. And over the career, if you go to the WNBA, you would shoot thousands of them. So why don't you make that shot like 1,000?
You want me to make it 1,000?
I want a bunch of shots, or maybe 100. Let's just do 100.
Oh gosh, man, I just hit enter and I know better than that.
So she's going to shoot 100 free throws and it's going to go a little faster. Now it's, and
why if I hit, what is happening?
I don't know. It's you're a rock star now. Look at you. You're in the 90s.
How do I just hit like 16 in a row correct?
She was a hot shot right there. But that actually brings up, there was a string in the Super Bowl where there were like 12 heads in a row, 12 games. The coin landed on heads for 12 consecutive Super Bowls. And everybody was then people started to bet on the coin toss. And I mean, it's over long haul, over 100. You're going to eventually get back to whatever is the norm. Now,
do we feel like, after 124 shots or 113 shots or whatever, like, do you begin to trust somebody if they say, man, I've shot 200 shots and I got it right 84% of the time? Like, is that more believable than after 3?
Yes, I would want to see more data. And I think that's very intuitive. You're not going to believe somebody on just 1 or 2 fluke. And if you do, you're not really a statistician.
Right.
Okay. And even after 200, it's very unlikely that it's going to be perfectly at 80. Of course, I say that it's right at 80 right now.
I don't think in the number of times I've done this that it's ever been exact.
It's exactly 80. And I just literally said that right as she did it. Okay. But it wouldn't bother me if it was 81 or 78, but it's going to be 80-ish.
Yeah.
Her true percentage is actually 80%, or at least the way it's set up in this. So if Miss Young were to go out on the basketball court right now and shoot 200 free throws and only hit 40 out of 200, then I'd be a little more skeptical.
Right.
Okay.
Right.
All right. So let's do this with something that has a little. Can we go on to the next one?
I would love to. I'm
This
trying
is one
to
of
move
my
everything.
favorite websites and one of my favorite topics because it's going to make you mad. Everybody's gonna be mad one way or the other. You
So we
can't
tend
win.
to get like stuck in our heads that simulations are mathy and they don't like exist in real life, and like we
They're
get
for
confused
games and
about.
gambling and stuff.
Yeah. So, when somebody says, like, oh, well, it was predicted that so and so was going to win, how do you think they predict that? Okay, so here we are
This
at,
website's 270 to win. It's a political website, and they use polling data to predict or to estimate what's going to happen. If you scroll down, there are certain states that are almost guaranteed to go one way, Biden or Trump. And today is October 19th. You may not be watching this until after the election. I don't know when this is mapped out. But we're predicting who's going
yeah,
to
this
win.
is definitely, I think, going to be, well, it could be like right at.
Yeah, it might be right around the election. And they may not even know on November 3rd. But anyway, there are certain states like Arkansas is pretty much a lock for Donald Trump, and California is pretty much a lock for Joe Biden, right?
So
Uh,
what's going to happen here is we're going to run a simulation, and it's going to give us who takes the state, um, we're going to just do based on poll closing times. Okay, so we're going to run a simulation, and this is how polls close. So this is how they'll come to us when we start getting information about, who's going to win.
and based on the current polling rates, now this is August or October 19th when we're running this, based on the polling on this day, they're using those polls and the chances of person winning each respective state. Now there's only about 8 or 9 states that are actually competitive right now, right? Every time we run this, California is going to be blue and Arkansas is going to be red.
Right.
But it's the Ohio's, the Michigans, the PAs, the Floridas. So she just ran it, and Biden just won our first simulation, and now we're running it again. Good, it's running much faster than it did.
It is. No, happy about
We
that.
were running earlier in practice, and it was really slow.
I was like, this is going to be real bad and boring.
Okay, so Biden won 2 in a row. So Biden's the president.
No. So, guys, what happens here is they don't run this once and say, okay, and then tell the world, like, looks like Biden, based on this one simulation. They're going to run this over and over and over and over and over again. And in fact, they're going to run it, and they tell you to get a more complete picture. We run 25,000 simulations each afternoon and then compile the results. And that's the information that's given out.
You've run it 3 times, so come on, let's run some more.
25,000 times. Okay, I'm gonna do it one more time.
Well, you got to do it 24,996 more times now.
I'm not doing it. I'm
You're
just
not going to
not
sit here
gonna
and
do
click
it.
and watch these states.
Yeah, but
You're
you
not
guys
gonna have
at home, feel free to like run this simulation and
Yeah, go ahead, and that's your homework to run it 25,000 times. Oh, wait, no, that's not it.
So, anyways, we wanted you to see another example of what a simulation looks like and just how relevant this can be to your like everyday world.
So can we see what they got when they did their 25,000? I think if that 25,000 number was a live link, wasn't
Yeah,
it?
I was just looking. Oh, there it is. Yeah.
Now this was, I don't know what day this. Oh, it did tell you up there. It each has it for August 7th. No, is that right?
There we go. October
Okay.
19th.
Oh, okay. That's October 19th as they were recording. So there's the distribution of how many times, and each of those is the how many electoral votes, I think. But it looks like Biden won 88% of their trials, okay, of their simulation. Now, that doesn't mean that Biden is going to be your next president. It just means that it's looking like that on October 19th. We still have, 15 more days till the election. Okay.
So, what do you think these boxes mean, Mr. Bobby?
Well, that's, I think, what I was saying earlier. There are certain states that the polling is so stark. Arkansas, Oklahoma, West Virginia, those states are polling currently, at least as of today, so strongly for Donald Trump that they're willing to give those to Donald Trump
Yeah.
with 99.9% confidence. And there are other states on the left side there that are so likewise polling heavily for Joe Biden.
Yeah.
Okay. So those aren't going to be contested. There are only a certain number. They have the ones above them relatively close. Like I know, I used to live in Ohio. Ohio is an extremely competitive state politically, whereas Arkansas is not.
You can look here right now. Trump is taking it, but not by much.
Yes. So that Ohio is one of the closest states. It's near 50-50. Okay. Pennsylvania is where I grew up. You can see I'm from, I played or played football, not for Ohio University, I played for Marietta College, and I played, Ohio is definitely the heart of all that. So,
Yeah.
All right. Anyway, let's go on and talk about some other ideas about probability.
So probability, we think about it being a long run relative frequency, right? We say the probability of flipping a coin is 50-50. You've heard that all your life. It doesn't mean that I'm going to flip it and get heads and the very next time I'm going to flip it and get tails. It means that if we flipped the coin a whole bunch of times, that long run relative frequency would begin to tell us something about the probability.
Many, many times is a phrase you'll want to use. If we were flip the coin many, many times, we would get approximately 50% heads, 50% tails.
Right. And then probability is always between 0 and 1. If you give me a number that is not between 0 and 1, you've lost your sauce. Think about it. If you'll think about it as a percentage, you'll be less likely to make that mistake. If you said, if the probability of something occurring is 0.37, what does that mean, Mr. Bobby?
0.37, I would translate that to a 37% chance.
Right. So if you give me an answer that's like 2.62,
that would be 262% chance of something happen. That makes sense.
Right.
You cannot give 110%. I don't care what your coach tells you. You can give 100%, and that's it.
No more.
No more. That ain't gonna happen.
And then we think about short-term probability as being quite unpredictable, like me shooting the basketball. And then we think about long-term being predictable, which you kind of saw. You want to talk about law of large numbers?
And that's what when we ran the simulation for the election, we ran it, I think, 4 or 5 times. And she got Joe Biden, I think, almost every time. Okay. But there are instances and there are ways that Donald Trump can win the election, and that occurred when they ran it about 12% of the time. So if any one of those, on November 3rd, anything can happen one time, but they're just using the simulation to approximate what might happen on the 3rd.
Yeah. So, are you ready? It's a textbook problem.
Okay.
Pedro drives the same route to work on Monday through Friday. His route includes 1 traffic light. According to the local traffic department, there is a 55% probability that the light will be red when Pedro reaches the light. Interpret this probability.
I think it's pretty impressive that they know about his particular driving habits, and that
I told you it was a textbook problem. They don't always make sense.
I know they don't always make sense, but I love that they were so focused that they could figure out about Pedro's chances of hitting the light. Not just mine, but just his in specific. If over the many, many times that he would drive to work, he would hit the light about 55% of the time, or 0.55 would be his probability.
And we're going to underline Many May because that's how my life is today.
Yes, use the word many, or Tracy, what do you use for the law of large numbers? Tracy has a goofy way of saying it, but whatever. She's not listening to me. All right.
Yeah.
That's supposed to be many.
Many. Gotta say that. And then there's one wishy-washy word that we like.
About
55%. Don't want to say 55% and insinuate that it is going to be exactly 55%. So we remember we're back. Here we are back at our wishy-washy words. About. Approximately is fine.
It's around, whatever.
Okay, so
Stick with me.
Probability is the measure of how likely an outcome is to occur. Match one probability to each of the following statements. Explain the answers to your neighbor. You can tell that I stole this from last year.
Okay. Oh, yeah.
Well,
When she was actually teaching people in person. So we'll pretend like we're each other, we're each other's partner. Well, if something can't happen,
it can never happen.
it can never happen. It's impossible, can never happen.
So what's something that could never happen?
Me making it to the WNBA.
Well, could you get you might be too old. You might
And I'm too terrible with basketball, and I'm, the only athletic ability I have is the ability to run into people, which was fine for being an offensive lineman.
the probability of rolling a number cube and getting a 7.
Yes, or okay, rolling 2 number cubes and getting a 17. That's impossible. And that is a big old squadouche. That's a 0.
Yeah, no probability. There's no chance of it happening. Its probability is 0.
Okay. So if something was absolutely going to happen, that's 100% lock. What's 100% as a number without a percentage?
It's 1.
Why do you always sing your answers? It's whatever.
Actually, just recently, I didn't realize that I always did this, but just recently, everybody's been talking about how much I sing everything. This outcome is very unlikely, but it will occur once in a while in a long sequence of trials.
Well, I want something that's unlikely. So it's, like 50-50 is a half. So I know I want those 2 that are below 0 or below 50, below 0.5. But I want something that's very unlikely. It would be the 0.001. 30% would be what the 3 is. And that's not, there's a 30% chance of rain. It could be rain, right?
So how about this outcome will occur more often than not?
I want the ones that are above 50% using my logic from before. So can I have 2 answers?
You can.
Okay, then I want the 0.6 and the 0.99. And I could even throw in the 1 because that's definitely going to occur more often than not, but that's kind of silly because it's always going to happen. It's never going to not happen if it's 1.
Yeah.
Okay.
A husband and wife decide to have children until they have at least one of each sex. The couple has had 7 girls in a row. Their doctor assures them that they are much more likely to have a boy next. Explain why the doctor is wrong.
Because he's not a statistician.
He's a doctor.
Yeah, he's a doctor. You don't know nothing about no statistician. Every birth is a 50-50 shot.
Yeah. You don't just magically all of a sudden get this like, oh, you had a bunch of girls. This next one's got to be a boy.
Yeah. No. Nope.
By the way, I do have a friend who had 5 daughters in a row. 5 trying to get a boy before she gave up.
I just get a dog.
Or 7.
Yeah, or you could have 7 dogs.
Yeah. Okay, guys, there is only one assignment attached to both of these. See how much we love you? Just Khan Academy, interpreting results of simulations. Good luck. Have fun. It was good hanging out with you. Bye.
Bye.